In this video, I'm going to talk about the limit of rational functions. So let's begin with the definition of a rational function. A rational function fx is usually the division of two polynomials like px divided by qx. So any division of two polynomials is a rational function. Okay, so for example, f of x equal like x to the power of 5 plus 2x plus 8. So it is a rational function of order 5, of degree 5, and that's the polynomial numerator, that's px. So we need another polynomial in the denominator, so let's say it is, for example, x to the power of 8, okay, minus 2x to the power of 8 plus 3x to the power of 4 minus 3. So you can see we have two polynomials. Numerator is a polynomial of degree 5, x5 plus 2x plus 8, and in denominator we have another polynomial. This one is of degree 8, negative 2x to the power of 8 minus 3x4 minus 3. So division of these two polynomials, fx, is a rational function. So now, if we're going to talk about the limit of this type of rational function, so there are three situations. Okay, the first one is, let's talk about the limit of, for example, we're going to talk about limit of px by qx when x approaches a. So we're going to talk about different situations for this limit. The first situation is when you plug in a into qx, okay, so like qa is non-zero. So what happens? So when the value of function qx at a is non-zero, so then that's the simplest case. So actually the limit px by qx when x approaches a. So it doesn't matter what px is. We don't look at function p. P is just a polynomial. Doesn't matter which degree is what this one is. The limit is just plug in a into px by qx. So the answer is only pa by qa. And that's it. That's the solution. So when qa is non-zero, limit of px by qx is just pa by qa. We just plug in. For example, limit of okay, so now when x approaches, for example, to 1. So here a is 1, so a is 1. Px is the function in numerator. This one is px. And qx is the function in denominator. So this one is qx. So first thing first, we check qa. So qa, so it is actually q of 1. So I'm just going to write here q1. We just plug in. So it's 3, 1 to the power of 2 minus 5 times 1 plus 1. And the answer is negative 1. So it is non-zero. qa is non-zero. So that's the first situation. So we can say, okay, the limit is equal to pa, let's say a here is 1, so I just use 1, pa by q1. So what is the numerator? We just plug in 1 into px, 2x4 minus 8x plus 2. So the answer is negative 4. and denominator is -1. So what is the limit? Limit is 4. Okay, so the first situation is easy. We just, at first we check the value of polynomial denominator qx at a if it's non-zero. So that's it. We just, the limit of px by qx is just pa by qa. We just plug in a into the function px by qx. Okay, what about the second situation? Okay. Okay, the second situation is, so when px, when qa is 0. So now what we're going to do, so the denominator is the denominator is 0, the value of qx is at a is 0. So now it depends on what happens to p. So the first case, the second case, the second situation is when pa is non-zero. Okay, so when qa is 0 and when pa is non-zero. So for this situation, what we need, it's obviously for this situation, the limit is positive infinity or negative infinity. So one of these two will happen. Okay, so when qa is 0, pa non-zero, the limit of pa by qa is always positive infinity by negative infinity. But which one? So that depends on the polynomials we have. Okay, so let's solve an example. Limit of, for example, x squared plus 1 by x minus 1 when x approaches 1. Okay, from right. Okay, so what about this? So if we just try, so qx is the x minus 1, so qa, let's just give 1. If you plug in, it is 0. What is px? Px is x squared plus 1. That's px, so pa, which is p of 1. So it's obviously 2 non-zero. So denominator is 0, numerator is non-zero. So the limit, we know it's positive infinity or negative infinity, but which one? Now we're going to talk about it. So usually for this situation we say, okay, so this limit is actually 2 by 0. So numerator is 2, when we plug in 1 is 2, denominator is 0. But when we say limit, that means x approaches to 1. Okay, so when x approaches to 1, the limit means we're going to find the value of x minus 1 when x is so close to 1, not equal to 1. So x minus 1, the 0 we have in denominator, so it's not actually 0, because in limit technically we don't plug in 1. So because we're just going to try the values of x so close to 1, not x equal to 1. And so that means x minus 1 is not actually 0, it's a number so close to 0. For example, when x is 1.001, okay, so it is a number so close to 1, bigger than 1, because x approaches to 1 from right side. So now if you just find x minus 1, so it's going to be 1.001 minus 1, and it is 0.001. So you can see it's a number so close to 0, okay, but it's not 0. So you can choose another value for x which is closer, even closer than 1.001 to 1, but not 0, but not equal to 1. So you can see again x minus 1 is a number so close to 0, but it's not going to be 0. But you can see this 1.001 0.001, it's a number so close to 0, but it's not 0, okay, and it is positive, okay, it's a positive number. So we can say actually here, we can say it's 2 by 0 positive. 0 positive here means numerator approaches to 2, but denominator approaches to 0. It's not going to be 0, it approaches to 0 by positive values. So here it means the numerator is positive, denominator is positive, so the limit is going to be positive infinity. Okay, and so that's how we can find, okay, which one it is, okay, positive infinity or negative infinity. Okay, let's have another example. Okay, so for example, the same limit, but this time I'm going to solve it for x approaches one from left. Okay, limit of x squared plus 1 by x minus 1. This time x approaches 1 from left side. So now what about this one? So again, you can see it is two by 0. So numerator is 2, denominator is 0. We need to find the sign of denominator. Is it 0 positive or 0 negative? So that's easy. Just choose a number so close to 1 but less than 1. So like x equal 0.999. Okay, so what is x minus 1? So it is 0.9 minus 1, 0. Which is this time it is negative 0.001. Okay, so you can see again negative 0.001 is a number so close to 0, but this time it's a negative number, so it's going to be 2 by 0 negative. So this time, so the numerator is a positive number, denominator is a negative number, so division of a positive and negative number is going to be a negative number. So actually the limit will be negative infinity this time. Yes, so that's how it is. And you know, the graph of function at x equal to 1 when here is 1. So this time, you know, in this case we say x equal 1 is the vertical asymptote for this function. And if you're going to draw it, I'm just going to draw this function round x equal to 1, not the other parts. We have just information about the limit at x equal 1. So the right limit at 1 is positive infinity, so it's going to be something like this, and left limit is negative infinity, so it is this one. So this function around x equal to 1, it's something like this. Okay, so it is the second situation when the value of denominator is 0, the value of numerator is not 0. If you have time, so I'm going to solve a few more questions at the end. What is the third situation? Okay, just okay, so the third situation we have for limit of rational functions, it is when q of a is 0, the value of denominator is 0, and also p of a is 0. Okay, the value of both polynomials in numerator and denominator is 0. So it's kind of, you know, it's usually when we're going to show it, it's say, okay, so this limit is 0 over 0. So for the situation, the limit is 0 by 0. We need simplification always. For rational functions, we always need simplification. So what is simplification for polynomials? It's usually using the factorization. We factorize numerator, denominator to find the common terms, and then we simplify. You know, the easiest example I can say I can give here is what is the limit of x squared minus 1 by x minus 1 when x approaches to 1. Okay, so this limit is limit of, so you can see, let's check which situation it is. Then we start this solving the limit. So if we try, okay, so what is qx? Qx is x minus 1, px is x squared minus 1. So now q of 1 is just 1 minus 1 is 0, p of 1 is also 0. So it's a 0 over 0 situation. Now we need to simplify. To simplify this one, we say this limit is equal to its limit of x approaches to 1. What about numerator? If we factorize x squared minus 1, it's x minus 1, x plus 1. What about denominator? It's just x minus 1. So now we can see there's a common factor between numerator and denominator. So x minus 1, x minus 1. So we cancel x minus 1 by x minus 1. And so this limit is going to be limit of x plus 1 when x approaches 1, and the limit is going to be 2.